So our last piece here is going to be in regards to applications. So all these pieces that we're finding, the vertex, the intercepts, what does it mean with a word problem? So for our first example, we have a toy rocket is shot into the air at a speed of 48 feet per second. Its height after x seconds is given by y equals negative 16x squared plus 48x. So I know we have the graph on that right-hand side, but just for the sake of practicing our properties, does the parabola open upward or downward? Well, I'm seeing a equals negative 16 here, and I'm seeing a b equals positive 48, and I'm seeing a c of 0 here. So what that's telling me is if a is negative 16, because that is negative, our parabola opens downward, which matches our graph to the right. Also makes sense in terms of a toy rocket being shot up into the air. It's going to go up and then come back down, so that shape is going to need to be opening downward. What are the x-intercepts? So what we're going to do is solve them, but we can see them in their graph over there. But let's go ahead and solve. 0 equals negative 16x squared plus 48x. I can go ahead and take out a greatest common factor of negative 16x, which will leave me with an x minus 3. So I'm going to end up with negative 16x equals 0. I'll write this up here. Negative 16x can equal 0, or x minus 3 equals 0. So will give me x equals 0 and x equals positive 3. So those are my two x-intercepts there, which I'm seeing in the graph. So let's talk about what that means in context though. What are those two coordinates showing me? Well, what they have shared is when there is a height of 0. So for both of those cases, this is where height equals 0 feet. Or you could think of this as ground level. So it's like our toy rocket is starting on the ground, it's going upward, and it returns to the ground after 3 seconds. So that's something we're seeing here is the rocket hits the ground after 3 seconds. So it starts at the ground and then it returns to the ground. What is the y-intercept? So that's plugging in x equals 0, and in this case, it's going to be equal to 0. So this is the height at the beginning. This is like our initial height. So we have an initial height. So before time starts ticking, we have an initial height of 0 feet. Okay, so just looking at this graph, we really talked about the intercepts here, so where the height is 0. Also the idea of what's happening when time is 0. We have some other coordinates here, and we'll talk about the vertex a little bit more on the next page. But just think of each of these coordinates as telling you a time for the x-coordinate and a height. So like that 232, we could interpret that of the toy rocket has a height of 32 feet after 2 seconds. But then that actually happens in another spot too. It has a height of 32 feet after 1 second. So after 2 seconds and 1 second. So it's going to reach that height in 2 spots. So that happens a lot of places here. Like if I looked for when does the rocket have a height of 16 feet, there's 2 points in times because it's going up and passing that height. And then as it's coming down, it's going to pass that height again. But then we have this maximum height that's coming through in the vertex, which we'll talk more about on the next page. Okay, we're going to go ahead and skip that part D there that's on your worksheet. So don't worry about what domain and range are. We'll talk about those later in the term. We have a rock is thrown into the air off of a cliff. and travels upward before turning around and falling into the ocean. So just as a little image here, we have a cliff, we have the ocean, we are standing here, and we're throwing a rock off the cliff and into the water. Okay, so there's our formula. So how long does it take for the rock to hit the water? So what we want to do is know when is that height equal to 0. So we're solving 0 equals negative 4.9t squared plus 10t plus 50. Now, this is pretty messy, so I think I'm going to go straight for quadratic formula here, where a is negative 4.9, b is a positive 10, and c is 50. And we're solving t equals negative b plus or minus root b squared minus 4ac all over 2a. And then we'll plug in our values. And then this is going to be messy, so we're going to just go ahead over to the calculator to help us out. So let's go to the Desmos Scientific Calculator and plug these in. So I'm going to separate up my fraction, and then I'm going to have a negative 10, and let's go ahead with plus the square root of 10 squared minus 4 times negative 4.9 times 50 all over 2 times a negative 4.9. So that's giving me a negative 2.33. Let's go ahead and write that down as one solution. And our other solution is where I'm just going to edit that notation so that I have subtraction between them. So I'm going to subtract that addition, or take out that addition and replace it with subtraction, which is a 4.37. Now, with this, it doesn't make sense to have negative time, so we don't want to use that answer. Our one and only answer is the 4.37. So the rock hits the water after 4.37, and we're working with seconds here. And I'll do it. Okay, let's talk about the vertex and how that relates to minimum maximum. So if our parabola is opening downward, that's going to a maximum point. So we're getting this maximum value for y. It's going to be the largest y value in our entire equation. If our parabola opens upward, that's creating a minimum value, the smallest y value we could possibly have. So going back to that toy rocket, if we wanted to know what is the maximum height of the toy rocket, we want to look at that vertex. So that vertex is right there, but let's go through the process of solving for it just for the sake of practice. So that'd be negative 48 over 2 times negative 16, which should be 1.5. And then we could go to y equals negative 16 and plug in 1.5 for where x is. And that should give us that matching 36. So with that, the x value is giving us time and the y value is giving us height. So they're asking for the maximum height and when does it reach the maximum height? So the toy rocket reaches a maximum height of 36 feet after 1.5 seconds. And that's how we'd interpret it. Okay, let's say we go back to the cliff and we're throwing the rock off the cliff and we want to know what is the maximum height of the rock and when does it reach this height. So again, we're going to find our vertex. So as soon as I see maximum, I'm thinking vertex with our quadratic equation here. So I want to find the vertex, which is our negative b over 2a, which will be negative 10 divided by 2 times negative 4.9. So let's go ahead and solve for that in Desmos. So we'll have division with a negative 10 divided by 2 times negative 4.9, which is about 1.02. And then to get the height, what I'm going to do is plug that in for t. And we could go ahead and use Desmos to help us out there as well. So negative 4.9 times a 1.02 squared plus 10 times 1.02 plus 50. So that's giving me 55.10. So the rock reaches a maximum height of 55.1 meters after 1.02 seconds. So for intercepts, you're plugging in values of 0, and then for minimum and maximums, we are looking for the vertex.